So before we proceed, you have 10 minutes to relax and listen to me until I explain the app that we'll use today. Please, everyone, make sure you have Git installed locally and Docker installed and configured. Configured means you can run Docker PS and it doesn't throw any failure for you. That means you don't have any permissions with Docker, especially if you use Windows. Anybody here uses Windows? Cool. Wow. Okay. I hope we'll have a lot of fun. Well, actually, with last years after Windows released WSL2, it's way more convenient than using MacBook for development. So it's pretty okay. So we'll start with listen to me for 10 minutes, and if anybody has failures with Git or Docker and can't solve it yourself, please let me know. I can help. I'll first explain the app. So I wanted to use some front-end app today just for visibility to make you guys easily understand what I'm talking about. If I can move this video out, yes. So for this, I built first backend and frontend, and we will focus on frontend and its testing today. So for backend, I created a little REST API in a language called Darklang. Anybody has ever heard about it? Yeah, it's in private beta mode. That's why probably. And this is a tool that allows you to really quickly create a backend, mostly REST API in a few clicks. And it looks like this. So we have a web page, for now only in Chrome browser, where you have some objects like database, and you create an endpoint like this, and you can get all objects, some particular object by ID, or you can create objects or delete it in a very, very simple way. They have their own syntax, and I hope it will be in some public stage soon, and we'll enjoy it with some self-hosted services. What's the biggest benefit of it? We don't need any Git, we don't need any metrics or any other layer of application. So once you have it, you already have it deployed. Once you have any change, it's deployed automatically in milliseconds. We'll not go into details a lot. Just to quickly explain, there are three objects. It's kind of fake payment portal where we can create and get objects like merchants, users, and make payments. So I can create a consumer of a shop itself, and make a payment between them, and I can delete all these objects. So that's pretty much it. And I built a little front-end app in Vue.js with a pure JavaScript, where I can just read all the stuff and show. I'm very bad front-end developer. Sorry for my front-end skills. I hope it will not hurt your eyes. For now, it looks like this. So I have users. I can create one. Let's say Alexander. I'll switch caps lock. And my phone is something like this. And I have some account number. I can create it. Once I create, it's appeared here. And I can create a merchant. Shop 1. Blah 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 strat 3, and account number 1231234. So there is some functionality. You can imagine some test cases that I will cover later. So object is created, it's updated, it's in a table. We generate some UUID on the fly for it, and we update the total amount of its objects in the system. So instead of copying manually the IDs, I created a functionality to copy ID from here. So I can copy its ID, and I can go to users and find the user I just created, copy its ID. And I can go to payments, and I have pre-filled user ID and merchant ID. I can make a payment of 123 whatever. And it's, where is it? It's here. So I see the accounts that I just used for creation. So this is the simple app, and I can again delete it from here. I can delete merchants, and I can delete user, that I just created, so it all works. And this app is already deployed to render.com platform for free. Works pretty slow. Yeah, and if I deploy a new version, I will need to wait a few minutes. So render is another app that you can use for purposes like this, where you can release and deploy your web services or some microservices for free. And by default, you have some features available. It will create a hosting for you based on your Git repo. It will have some events. It will show you some logs. And it works really, really slow because I use a free version. But what we will start with is understand how to test it locally, because with the modern world, we need to focus on finding problems and bugs on the earliest possible stage. It's called left shift testing. Means we capture bugs on the development stage, so we don't really even deploy the problematic code to some environment, not talking about production, but any environment. It helps to reduce the amount of bugs. It makes developers happier because they don't like to fix some bugs until it's not a bug, it's in development stage, it's a problem, ongoing issue, right? And of course, we can go to the market quicker. So we will try to test this app on localhost. So what I will do now is I will try to spin this app on localhost. So I have this, come on. I have this Git repo, clone it locally, and I listed just a few requirements that I require some specific version of Node and specific version of NPM. So if you want to run this app locally, you need to have all these dependencies, plus it can depend on your operating systems. But the Node, especially with Node, it's sometimes very specific to your other setups. It can even adopt about some Python version for whatever reasons in some particular Linux systems. If I want to quickly spin it up locally, I can go to terminal. Portal payment app. Can you see this good enough? Right. So what I can do, I can make it a bit bigger. There is a README file that has some stages. So first stage is npm install, what this command does, who work with JavaScript knows, it will pull all the packages that we have as dependencies and transitive dependencies for our project, and it will create a folder called not modules. It will appear quickly here. So this folder, we don't need to commit to remove Git repo. We just need to have it locally, because depending on the system, everyone will have different versions. And now once I have this not modules, I can run npm run surf command that is listed in my package.json under scripts. So surf command actually runs some view command that will spin up this web service in a local host with the port 8082. So it says it's up and running, so I can actually open it in my browser. So you see the same front end that I just showed with the real app deployed to public host. So I can have it up and running. So what we will do now together is we will try to clone this project and run locally in Docker, slowly, step by step. So what we will do is we'll get this project and clone locally. For this, please open github.com. Does not matter if you're logged in or not. It's public one, and in a search type portal-payment-app. Portal-payment-app, and I'll be short one in this search under Alexander Chumakin /portal payment app. Let's give everybody a few more seconds. Looks like success. So you go here. There are multiple ways to clone this project. I prefer this by HTTPS, so we don't need to take care about SSH keys. So you click on this green code button. You make sure you're on local tab, and under HTTPS, you can click copy button that will have a git link with HTTPS prefix to this project. Let's give everybody a minute. Okay, so I hope everybody copied. So whoever uses Windows, please make sure you don't use a standard terminal, but you either use a PowerShell or Cygwin or whatever you have. At least everybody has PowerShell. Whoever uses Mac or Linux, it does not matter. Everybody will be good. So you can go to any folder. I will create a temp project, temp folder for myself. I had it. So I have a folder where I will clone. To clone this project, I will run the command git clone, and then I'll paste this HTTPS link. If you have SSH keys to GitHub, you can use SSH link as well. And this command will clone this project from GitHub to your local host. So let's give everybody a minute to clone this project. All right, so there are a few ways to check that this is cloned. You don't see any failures. If you run a simple ls command that will even work on Windows in PowerShell or any Linux terminal like Cygwin, it will show this project is actually here. So you can switch to this project. And depending on your terminal, you will see different output, but you should use any terminal and be switched off into this project. Okay, so I hope we are all good. Let me know if not. So if you just try to do the same actions as I just did before, a lot of you will have problems because of you don't have Node, NPM, or you have different versions that don't support this project or any other dependencies. So if I run locally node -v or npm -v, it will show the versions of npm and node that I have in my local laptop. You might have different, you might don't have it. So to make sure we don't depend on operating system and tools installed, we will start using Docker. So the first question of when we try to run something in Docker container is what version of Docker to choose. Before we start using it, we'll try to understand what is actually Docker for our case and what do we need from it. So imagine you have any working station, your laptop, any remote host, any virtual machine or burst server, and you don't want or you cannot, because of permissions, install some software like Node in this case, right? And you want to use a Docker container to be able to run this app using Node, Java, PHP, Python, whatever is required to start this app. but being completely agnostic from workstation. So I want this to work exactly the same in Linux, Mac, Windows, any versions, and in CI as well. So to make sure it works in this way, we can use a Docker container that is actually a little operating system running in your computer or in any virtual machine, and completely agnostic from what workstation do you have. So it has its own operating system, but the pre-installed tools, you can install something else on the top, and you can communicate with this container by two main ways. First one is via files, so you can share files and folders between your workstation and Docker container by volumes. So you bind volumes and say Docker container, please use this folder by this path, and this is what I have locally. So you can share files from your working station to container and vice versa. And the second way is via ports. So you can start some app in a container in some port. You allocate some port inside container. You allocate some port in your working station. You connect these ports, and you can use in service inside Docker container in your working station. This is what we'll do now. So the first question is what image to use to start a container. Same as all times we installed Windows locally, we needed a disk with the ISO image to install this Windows in your laptop. Same, we need an image of Docker that will be used for starting of our container. For doing this, we can always go to Docker Hub. Dockerhub.com is moved to hub.docker.com, and here we can start searching for images that we need. I know that my app is built in Node, so I will find for Node images. My suggestion is always try first to start with the official images. It will be marked here as Docker official image. You can see it as well. Is it better? Cool. Sorry. Yeah, let me know if it happens again, because I see it really well here. So usually the image that you will find, especially if it's standard image like Java or Node or NPM or whatever, will be on top, and it will be marked with this label Docker official image. If you have specific needs, you can use non-official images, but always check what it uses under the hood, because it might have some vulnerabilities, it might have some specific implementations, so make sure it's official in your company to use non-Docker official images. You can always check some filters in the left to only find official images, verified publishers, and so on. So in our case, this one will be good. So now we need to find a version of this image that is called tag. Docker tag, oh my god. I think it's something with internet here. Funny. This is, yeah, organizers promised it will not happen, but yeah, who will believe? Well, this is funny. What I'll do now is I'll tether my mobile internet to this weekend phone.
We use Opera with VPN.
Or yeah, as well. Come on. All right. I hope it will load for you soon. Yeah, fingers crossed. So you go to tags, and you can see a lot of versions, especially for official images. They can release it multiple times per day. So you see the latest one is published 18 hours ago, and it's really hard sometimes to find the right image. So what you should focus on is to find a right version. I know from this README that I just showed is I need a Node version 16. So this is what I'll try to find. So if I type 16 here, everything contains 16 will be applied, so 18.16 and so on, but I need 16 dot something. I just know that the latest 16 is 16.20. And there are again a few versions of 16.20 images. Means this is an image based on some Linux image, does not matter for now which one, with some additions and at least installed Node and NPM that are compatible with each other. This is what we need. There are a lot of subversions like Boster, Bol-C, and so on. So we will try to start with the normal images. But the problem with the normal images like this one is they are huge. This 16.20.0 is the latest subversion for image contains Node 16, is 300 plus megabytes compressed. So uncompressed it will be up to 1 GB depending on operating system. So what you should also try when you start using Docker is to start using slim images. So here if I type .0-slim, it will find an alternative of this image that I showed, but slim means with less possible dependencies installed for this little operating system image. So this is just 60. I hope it will be handled by our internet we all have. So if you click on it, it will show you the full image with a tag, and this is what we will pull now. Pull, same as with Git, means it will get this image from Docker Hub and pull locally. So you can upload a terminal, and you will type docker pull, and then we need to call the correct image name. So it will be node, then colon, and after colon you type the version, that is in our case 1620 slim, 1620-slim. And let's hope you will not be blocked. So it will take a couple of seconds ideally for everybody to pull it. I faced it a lot with the big Docker images in the past for previous workshops and conferences when it took up to 1 hour depending on the internet. Hope it will not be our case today. Does it work for anybody? Cool. Let's wait until it's cloned. So, and the size of the image that you saw here, that is in our case 62 megabytes, will be different one once you clone it locally. To check this one, you can do it in a few ways. Easy way, that is docker images command, and we can use grep. I hope Windows user will have it installed in PowerShell by default, but depends on Windows version. So Docker images will show you all the images. We only need to show node image for now. So you can use grep command, and if it's one word, you can skip double quotes, or you can always use it. So if you type node, I will have a lot of node images probably. Of course, I will search for the version 0-slim. So locally, when it's unpacked, it's already 170 plus megabytes. It will be different in all the laptops, depending mostly on operating system. Or there is a nice way to find this image without grep command. Docker images -- filter equals to reference equals, and then in double quotes we can actually fill in either the whole image name or just tag, or use regular expressions. It's much more handy. Node. This way is of course much more visible, because you also have names of the columns that is printed out, and you can use again regular expressions. So I hope I have a non-slim version as well. And this is a big difference, right? So before I showed the same node image that is non-slim, so unpacked locally is more than 800 megabytes, and it's raw operating system. Imagine you gone.
Sorry to interrupt. What is the difference actually between these two
Commands?
images?
Yeah, they are. So for our purpose, there is no difference. This is Yeah, there is no difference for our purpose because I just need node, npm, and that's it. In full image, there are much more tools. There will be curl, wget, a lot of Linux commands that we don't need for this session. So for many purposes, you might need to use a full image version, and this is a problem. Because imagine you have this 800 megabytes image as a base image, and you will have your app built on the top, and it will be a few GBs. But yeah, we'll talk about size a bit later more. But yeah, the idea here is to try to find the easiest possible way to find an image and try to find a slim one. So if it's enough, then it's cool. If there is like one tool missing, you just need curl. It's sometimes easier to just install curl inside it yourself and not spend another half GB that you will need to move across all the machines and especially to the environments. So we'll start a container now using this image. To start a container, we need a command docker run. Docker run starts new container based on the image. So after docker run command, you can immediately type the image version, and you can send some arguments or command line or entry point. I'll go to details later. So I will get just this image. So I type docker run node colon 1620o-slim, and from this image I want to just run a shell command. So I will switch from my macOS terminal to Linux terminal of this Docker image. Yeah, it does not work because I need to start it interactive mode to be able to work with this shell command. So there is a first set of flags that we'll use for Docker command, -it, that means interactive, and tty means you can send the input to shell and you can get the output from shell. So now I have a new terminal running inside my terminal that is actually Docker container. So now I'm in a completely different operating system that is built inside this node image. So now if you all type node -v here and npm -v here, you will have the same version of node and npm locally. It does not matter what operating system do you use and what have you pre-installed there. And this is one of the biggest benefits of using decontainerization. So now if I need to start my app, I need to have this app in this container, but I don't have it yet, right? So if I run ls here, yeah, it's just I'm in the root, but there is no such folder. So what I'll do is I will exit from this image with exit command, and I'll extend the previous command a bit more. So after -it before the name of the image, I will send one more flag -v. That means volume, and I will need to pass a path to folder on localhost to the path of the folder in my container. So on left, if it's always a path to where I need to get the project. Because I'm already in this folder, right? I'm already in portal payment app folder. I need to send an environment variable that has a path to this folder. It's always an environment variable pwd. Because of we have Windows users, we'll use the same syntax. It's $ curl brackets and pwd inside. For non-Windows users, you can skip curl brackets, it will work as well. And this is environment variable that exists in all operating system and has a path to your current folder. Then after colon, we'll create a path inside the container. You can call it any way you want. I will just call it app. So this is the whole command. Docker run -it -v, then double curl brackets pwd colon /app or / whatever folder you want to create inside your container. And now, when I'm inside the container, I can go to root app, same as I did here, and I can run the command ls, and I have all my project files inside the container. So this is the first way how you can operate with your folder or with your files between your workstation and container. Sure.
Are the files linked or they're moved into?
No, they're linked.
Just linked.
Yes, they are linked. So now we will run the command npm install. Yeah, it will take some time, so I have some time to explain. So actually now we have this folder mounted from our workstation inside the container. But mounted means bind. It actually links, so it temporarily creates some temp folder. It creates some files there, and then these files are linked between your container and operating system. So it's always, it's almost the same folder. There is a little state that can be changed in a few milliseconds or seconds, depending on your laptop. But in this way, you can create files in your workstation, and they are visible in container, or vice versa. So we'll build this project dependency that is Node modules folder inside the container, and you will have it in your operating system. So this is the first purpose where you can use Docker container in real work. So you can get some project, and if you want some output from this project, it can generate some image, HTML page, or whatever static object. You can just mount your folder inside the container, and you can run some command inside container. You can exit from it, and you have still outputs that is generated inside the container in your workstation. You can use it quite a lot, especially for complex setup like Java related stuff, where you don't need to take care about all the environment variables, this JVM, JDK, home, GRE, and so on. You can just simply get the right image, run the command, switch it off, and have the output locally. For me, it's finished, I guess, not for everybody, right? Cool. So the second command that I use to serve my my web service is npm run serve command. But if I try to run this, yeah, it says app running at localhost, but this app is running inside the container. So if I try to open it in my browser, it will not work because I didn't do the second part, that is TCP IP connection. And even if this app is running inside the container, I need to explain my operating system how to connect a particular port inside my container and mount it to my real operating system. So what I'll do now is I'll stop it with Ctrl+C, then type exit again, and with the previous command, docker run, I will extend it again a bit. So before, it doesn't matter the order, you can type it at any place, before here, the only important place is to type it before the image name. I will send one more flag -p that stands for port, and I'll mount 8082 to 8082. Does not matter. This one is in right, it's always container, it's always Docker one, and in left is what you allocate for this port locally. So again, if I'm here, I go to app. I already have Node modules built in the previous step, so we don't need to rebuild it again. You can always check it with ls command. There are a lot of versions of ls that you can use, for example, with the flag LAH, that will show all the files, even hidden, in human readable format. And Node modules is here. So I can run again npm run serve, and it will start the web service in port 8082. And if I get this one, so I have it finally working locally. So we all can spin up my app that I created with a very custom, quite old version of Node and npm, and all can run it locally without installation of this particular version of software. And this is, yeah, again, what you can use at work a lot, especially imagine you have Node or any other programming language with the newest version that developers use, right? Or any other team use, and you don't need to downgrade it, but you can use specific Docker image and build and run this inside the container and have it up and running locally. So we finish with this part. So we have a workstation, we have a container running it, we mount port, we mount files, folders, and we can use this container to build and serve the service. Any questions here?
I couldn't run Docker run that if not I have a problem, I don't know.
Let me quickly check.
It's actually running. Okay, so we are on this, right? So we run the same command. So we provide minus B different key for
Command I couldn't run.
Yeah, we'll run it.
Yeah.
Minus B slash. What? That's crazy keyboard. Right? So we can go to now in container it's already up. So if we run just install.
We need to
Yes, try to write I. No, type it normally. Yes. Yeah, it will run. After this, you run npm run serve, and then you can open in your browser.
Okay, thank you very much.
Okay, cool. Yeah, one more? Come from?
if you run Docker PS, so you see the but you don't need dash Docker, just Docker PS without. Okay. Windows, I don't know. It's always Windows with these kind of things. You have PowerShell as well?
Then after it finishes, I run VM run server. I anybody?
Still with the error that Docker requires credentials to be passed as a final frame. It's a command line. It's a regular command line.
Yeah, it's a very common thing. So what we need to do is we'll need to copy this no, it's about permissions.
Maybe you have to start Docker with admin.
It's about groups and permissions. Find groups and find Docker and make sure your user instances drop Docker.
Okay.
And then start this.
Okay.
And then just bless it and then.
Yeah, there are a couple of problems in Windows, especially with the Docker permissions. This is why, yeah, said it will be nice to have it pre-installed. We'll have a little break soon, and if anybody else have problems with this, let me know. I can try to help. Okay, so now what we did, we ran our app inside Docker container, but this is not real case. What developers do, they create their own image based on some base image with their app. For this purpose, we'll use Docker files. So to start exploring, you can just follow me, or you can open this in any terminal. You can use cat command. So we'll explore a little Docker file. I'll open it here just for visibility. And I go to presentation mode. So Docker file is a spec that explains how to build a new image based on some base image with some customizations that you might have. You can take a base image and install, for example, curl command and create your own image, or any other set of utilities you need, and again create your own images, or you can serve your web service or microservice inside this image and create your own image. For this purpose, you use Docker files. So this is exactly the same image that I used for Docker run command that we all just pulled. From row is usually the first or one of the first rows in any Docker files that explains what base image do we use to build our own image. So then you usually have a workdir command. Workdir creates a folder and makes this folder as default. So all the next commands after this one, until you override the work directory, will use this directory to run all the command inside. So then copy command. It actually does whatever I did with docker -v in run command. It copies all the folders and files inside your new image. So there is only one exception. Whatever you want to skip and not to copy inside your image, you can list in another file called Dockerignore. So let's go to this one. So in this project, I also have a gitignore Dockerignore file where I listed two folders. One is .idea because this is what was created automatically from my IntelliJ IDEA, and another one is not modules because I don't need this folder to be copied into the image, but I want to build it inside Docker file when I build a new image. So you can list all the folders and files you want to skip for copy command in your Docker file, and move to .dockerignore. The only requirement is it should be in the same folder where you execute the command docker build. We'll get to it a bit later. So then you can have a few run commands. It's actually what will be executed before new image is built. You can use run command for it. So once app folder is created inside this image, and all the folders and files except node modules and .idea will be copied inside this .app folder, command npm install will be executed. This is what we just did. And the spec will wait until go further before this is finished. And this is one more, quite specific annotation, expose. Does anybody really know what expose mean in Docker files?
Just
Cool.
maybe allow it to use that part.
So yeah, it actually not so obvious. I know it's a bit hard, and in many interviews you might hear this question. So when I ran container, I said -p flag that mounted a port inside the container with a port in my local host. Expose is not needed when you run it. Expose is only needed to work between different Docker containers in the same Docker network. I'll explain in more details a bit later. But again, expose and binding are different things. Binding just says, this is your local port, this is your container port, mount them. Expose means if you run multiple Docker containers inside one Docker network, they can talk to each other if you just expose the port without any bindings. But yeah, we'll get to it in like 1 hour. And then there are two ways to start some commands by default. It's not necessary. You can always type it manually, but I want to make my spec advanced. So one of the ways is to use cmd, means command that will be executed once you run your image. And I need to run just npm serve command, and I define it as a default command for my Docker image. So now we'll build this new image locally, and it will take some time, so you will have some time for questions. To build the new image, there is one more command, docker build. So there are a lot of options. Because we use Docker file with default name, we don't need to provide yet a custom name for Docker file. We only need to provide a tag version, an image version that we will build. So it can be done with a flag -t. You type whatever image name you want. So this is an image that will be built on top of Node with your Portal payment app. I will call it as is, Portal payment app, does not matter. And with colon, I can specify a tag. If you don't specify it, it will be latest. That is not recommended way to do, because you might want to rebuild a new version. It will be very hard to get the previous version because it's hashed. So I will use a standard like 0.1. First one means major version, and then minor version. You can be more specific, even .0 if you want, but I'll keep it as is. So docker build -t image name colon tag name. It can be numbers, it can be digits, it can be symbols, whatever you prefer, and then you provide a path to the folder where it will be executed. But I'm already in this folder, so I will provide a path dot, means current folder. So it will run all the specs one by one in this Docker file. Because it will not copy not modules, it will run the command npm install and will rebuild everything. So all the packages, all the dependencies and transitive dependencies are needed, will be rebuilt, and we will have a new version of image locally and only locally for now. And it will have your service built inside this image in your completely new image. While it's building, I'll explain. I know it will take some time. So because I didn't use any custom Docker registry, it will be docker.io. This is Docker registry of Docker Hub. So if you have your own Docker Hub username and password, you can now get this image and publish there in cloud for everybody. Or you can use custom Docker registry. Whoever used GitHub or GitLab or Artifactory know that these systems have their own Docker registry. So for your team, you usually create, for example, microservices and publish there, so only the team members can access it, sometimes even under a VPN only. So by default, if you don't specify one, you will have this prefix always, by this one. And the image is like we just called. So now I have this image and I can run this locally, right? So to run this, we'll use the command docker run again. And after docker run, I still need to provide a port. I will mount it to 8082 from port 8082 in a container. I don't need to provide a volume anymore because it's bind and built inside my new image. So I will copy this one that I just built and run it as is, right? So I only have docker run command with only binding port and this image that I built. If you called it in a different way here, it will reflect here. I don't need to run shell or anything because command is defined by default. So if I start it, it will take some time, and it says it's up and running. Let's see.
Why did you say that you didn't need the folder anymore?
Because in my Docker file, I already specified this part. So it copied everything and rebuilt not modules. So these not modules and all the dependencies are in this Docker image again already. So it's up and running. So I can start it. If I need to share with any team member, I can publish this image to Docker Hub or any Docker registry we use, and this person can pull it and start locally. And this is how it actually can work for real environments. I can already build the image, I can publish it for any environment like test environment and can start there. So any change I build locally and built inside this image will be reflected to this environment. The main problem with this image, with this container, is the size. So if I stop this one, sometimes it's really hard to stop it in MacBook. Come on. All right, if you can't stop it as me, what you can do, you can run the command docker ps in your terminal. It will show all the containers running, and you can kill any container manually with docker rm command, means remove. If you want to force kill it, you can use the flag -f, and you can either copy container ID or container name. I'll use container ID, and if I run docker ps again, it's killed, and my command line is free finally. Especially in Windows, it happens a lot, but in this nice MacBook as well, as you see. Yeah, you can use docker rm command to kill any container you want and make your resources free. So I will run the command docker images -- filter equals to reference equals to my image name, that is portal. So the syntax is filter equal reference equal double quotes. In double quotes you can specify either image name or tag or all together or any regular expression you want. And even with this little slim node image, it's already 400 megabytes with this super slim little app, and this is huge. You can imagine if you use non-slim base image, and this is real big production front end with JavaScript, it will be GBs, 3, 5. I've seen once 12 GB service, and deployment took like 2 hours because of the size, and network usage was crazy. So what we'll do now is we'll rebuild it, but with optimization. If we just notice the log from Docker container, it says no, that development build is not optimized, and it says you should use production builds. So not modules is a folder that contains an output of node-based project with all the dependencies, and it's huge. Sometimes this npm install might take hours in some machines to install everything because of the size and the amount of folders and files on it. So it's always recommended to use production builds. So for JavaScript or Node apps, production build comes with any library by default. In my case, because I use Vue.js, there is a command pre-generated, gone. And if you run npm run build, that is reflected to Vue CLI serve build command. We don't need to understand the details, but this is how Vue build production assets. So what we'll do now is we'll again run this production assets using Docker image and understand how it helps. So I make sure I don't have any containers running with Docker PS, and I will again run the command docker run -it -v $pwd. Again, if for Windows it should be in curl brackets. If it still does not work, right? Let me show how to do it quickly. You can use the wall pass instead of this one. I know in some Windows PCs it still will not work, so you can always either do it in a nice way like this one, or in Windows in curl brackets, or you can use the absolute pass of your app to bind inside the Docker container. So this is a hint for everybody whom does not this PWD work. I don't know why. It's probably some very old operating system, because from Windows 10 it always worked fine. Not sure. Just for your information. Gone. I'll do it in this way as previously. pwd -app and come on. It's node 16.10.0-slim, and I will run sh just to have the terminal appear. Is it not 16.10.0? 20. Alright, so if I switch to app now, I can run this command npm run build to generate production assets. Npm run build. It should not take so much time because production assets are really small. So for most of Node apps, production assets are set of JavaScript, HTML, and some media files like pictures and videos, built in one separate folder, by default called dist. So if I run ls, I will have a new folder dist that is really small comparing to not modules. So it's like bytes, no, not even kilobytes. And if I run ls command in these folders, I see some HTML, JavaScript, some images, some icons. So it's just output of my build in Vue.js framework. It can be done in exactly the same way for Angular or any other framework used for your front end. So now we need to have another container that is able to use these production assets, because if I open just this index HTML locally, it will be working but quite broken. So I need to serve these production assets, and there are a few ways to serve your assets. The very old way is Apache servers. I think nobody uses it nowadays. Another one is the most modern one is to use NGI-NX service. It's probably the most popular service to serve your web services for production. This is what we'll use today. And we'll not take care about the versions because they're very specific. We will reach out to another Docker file that I created. It's called Dockerfile prod. So for NGINX image, I got a tag Alpine, means kind of slim. It's really small Docker image that you cannot run with a simple shell, because this image serves something. So you need to get some production assets, bind inside this NGINX image to get it running. So there are a few commands that you can use in NGINX. Here, instead of cmd, I used entry point. That is another way to tell your Docker image what command to start once you spin up a new container from this image. In my case, I run the command nginx with the flag -d and say daemon off, because this is a service that we don't need for this case. It will just spin up this web service much faster without using of so much resources. So what we need to do is we need to, I first clean up everything that was in this image by default, and I say for work directory, user share nginx HTML, that is default directory of nginx. There's a big documentation of nginx. I just didn't want to spend too much time on it. It's default directory, and you can customize it with your nginx configuration that I want to skip for today. And I say get the whatever I have in this folder, right, that I just built, and copy inside this directory. So this image will only contain whatever has by default on it, plus my little dist folder. So let me build a new image using this Docker spec. Again, I make sure nothing is running, and I use the command docker build again. And now I need to provide a custom path to Dockerfile, because it's not just Dockerfile but Dockerfile prod. That's why I use the tag -f. And then you provide a name or a path to Dockerfile if it's inside the folder. In my case, it's docker build -f Dockerfile prod. Again, with -t, we provide a name of a new image that we will just create now. I will call it payment app prod. And with the tag, I'll use again the version 0.1. And again, the context where I build is current folder. That means dot. And if you hit it, it will be just finished right away, because it doesn't need to build something. It just takes, for your case, it will pull this nginx Alpine from a web, but it's really small one comparing to old images. Let me quickly check Docker images filter reference NGI-NX Alpine. It's 40 megabytes. So NGINX itself small. I use the version Alpine. Alpine is actually an operating system. It's Linux operating system, but specially built for Docker containers. You can't I'm not sure if you can, but it's meaningless to install Alpine in your laptop. It's the main Linux system, but it's very useful for to use it for your containers because it's super small. It almost has nothing by default except of a few very small commands. That's why they're really, really small. And it helps you to build your microservices or web services inside the image and take it really, really small and reduce the capacity on your network and speed up deployments. All right, so I have a new image called in this way, having these production assets that I just built. So let's start a container using this image to just make sure it works. There is a little difference in ports, because by default Nginx starts a service using port 80, and I didn't have a custom Nginx configuration, so I need to bind port from Docker container 80 to locally whatever I want. So locally I will still have 8082, but in Docker it will be just 80 because this is default configuration of Nginx. And then I will this time provide a flag -d called means detached. So this container will start in background. It will not take my command line, and in the end I just provide the name and tag of image that I just built here. Let's start it. As output for docker run -d, you have a big hash. Hash is actually a full ID of your Docker container. So if you type docker ps, you will see exactly the same hash, but short hash from this one. So when you need to kill container, you can use this hash, you can use this container ID, or you can just use a few first symbols. We'll show it in a few seconds. Let's see if it actually works. Reload. It is. So it's still running my app. And let's check the size of my app using previous method and current one. So I will run the command docker images filter. So this one that I just built now. So my app is built on top of Nginx. One is 42 megabytes against 400 something megabytes that was for development build. That's obvious because production build is a small one. So before we proceed, I will again explain. Docker ps shows the output for all the running containers. I have just one. This is the ID, or like how it's called, short hash, right? So if I want to kill this container, I can still use docker ram -f, and instead of copying the whole ID, I can just get a few first symbols, or sometimes even just one letter. So let's just use E96, or you can get a few first symbols. Because it's hash and I just have one Docker container, my Docker daemon understand what container do I want to kill by these few numbers of short hash. So docker ps shows I don't have any containers running. The only problem with this way is I needed to build this dist app, dist folder manually in different image. That is of course not real case for production builds. So there is the latest part that I want to finish before a little break. It's called multi-stage Docker file, multi-stages. So in your Docker file, you might have as many stages as you want, and every stage can prepare some outputs from your folder or from your project as you want. So in the first stage, I want to build node modules. This is where I need node, my huge node image, right? So then I need to prepare dist folder, and in completely different stage, I want to prepare the image that I just built here. So I want two stages in my case. First one will use node image, next one will use Nginx image. And from this huge full Docker file, I want to get my teeny little lightweight Docker image with my service in the end. Let's see how it looks in real world. I have another file called Docker file multi-stage in my project. So first, base image once you annotate it, you can call it any way you want, and you can reuse the output in the next stage. So after this one is finished, and this is a part that you already saw in Docker file, right? I only need to get dist folder, so I don't care about all my project, all my code. I don't need node modules. I only need dist folder from first stage, right? So with this annotation, with this pack, this command will create node modules. This command will create dist folder, and only thing that I need for the next stage for nginx alpine base image is say copy from builder folder created under app dist. App is because app is work directory, and dist is a default name of this folder that is created after run build command in npm, and copy on the work directory in nginx. So it will create node modules, it will create dist folder here in this stage, and in the second stage it will get a raw alpine image and will get this dist created in the first stage, and the rest is exactly the same that we already saw. So let's build one more last image.
So builder is the name of the image, a special name?
It's not an image name, it's name of temporary created image will be used in the second step. So it will not actually create an image for your
put
Docker.
that name on the
Yes, here. So run will run one more Docker build command. With the -f we provide a name to the file, Docker file multi-stage in my case, and with -t I create a new tag, a new image. I will call it portal app ms calls I don't know, final, with a tag 8.0, and dot means again I work in the current directory. So this is what the most of developer front-end developers use for their node based projects for real production. I hope it's your case as well. This is a way how you can prepare all the necessary output from your project and serve it with a little tiny final base image for your own image. And this is what actually using to host my service, my web service in render.com. So how I did it in settings, in case if you want to serve your own web service, I just create a path to my Git repo. If it's private, you need to provide credentials as well. I say the branch that I need to use, and I say the name of Docker file. That's it. So this on render.com gets this Docker file multi-stage spec. It creates its own image and run a container on it, and this is what I have here up and running. And this is how it usually works in the most of modern pipelines, let's say. So it uses multi-stage Docker file to prepare the final image, and it either releases it somewhere or some system like render.com get the spec and builds and run the new container on the fly. Let's see if it's finished. It might take a few more minutes for some of you because I'm using my internet from mobile, works a bit faster. So I only want to run and check that it works fine. So I'll use again the same command, docker run -p 8082 pointing to 80 because it's still nginx. And I'll run the flag -d to again run this container in detached mode, and we'll copy this image name that I just built. It's running. So if I go to localhost 8082, it's up and running. And the last thing that I want to check is the images. This size is the same, so I will again use docker images -filter equals to reference equals to this one, Yeah, and it's again about 42 megabytes. So with multi-stages images, you might have a little tiny image in the end, even if you had some intermediate images built from a really big ones. So what I'll do now is, I'll stop this recording. I'll start a new part afterwards. Yeah, I'll combine them afterward. So before we move to the second part, you can finish your coffee or water. You have another few minutes. But before we switch to testing part, because this is testing related conference, we'll quickly finish with one more topic that I didn't want to overload you with the first part. It's about Docker networks. So as I said, we use expose in a Docker file just to tell Docker container it should get this port available for all other containers in the same networks. And now we'll explore what is network actually. So first we need to make sure we have container running in case if you killed it. Let me kill it, -f e1, right? So docker ps shows nothing. You can always again run docker run -p 8082 or whatever port you want to allocate to 80 and use the latest image that we just prepared at the latest stage using multi-stage Docker file. And I will use again -d flag to start it in detached mode and not keep my terminal busy. So I want to have it running locally. So please make sure you have this service in container running locally. You can open it in localhost. So now, what we did, we ran this service in a container, but we tested and we used it only from our browser or terminal, but from your machine. What if, and this is what happens in most of real systems, CI systems, you need to run another container that needs to reach out some service in this container, the original one. So if locally I curl is a command to run some HTTP requests. I curl localhost 8082. It returns me the HTML, the same that I see in the browser, or you can use it for any backend testing as well. But this is because I can reach out this port 8082 from my machine because it's bind with a port 80 in this container. So what I want to do now is I want to run another container and reach out the original container with curl command. So I'll again use docker run command. Is the most lightweight container. I will use Alpine one. It has nothing in it. So if I run docker run Alpine, I don't care about the version. It will use the latest one. It's okay for now. Before Alpine, I will use -it, means interactive mode. Isn't it too noisy? Should I close the window? Right. It's almost peak hours. And I'll need to run sh, that is shell. So I'm now in Alpine terminal, but it does not have curl by default. I will quickly install it with apk add curl. It's really a little one, so everybody will have it in a few seconds. Now I have curl command, and what if I run curl 808 localhost 8082? It says I cannot connect. It couldn't connect to the server because it has no ideas what is localhost. It has only localhost inside this container, and we are not running this service inside this Alpine based container. We're running it in different containers. So if I run a new terminal docker ps, I have two containers running, one from image Alpine, another from image that we just built from the command line for our Docker file multi-stage. And this is where we have port 8082. Open it for localhost, but how can we connect containers between each other? This is where we need to understand the concept of Docker networks. So if you want to have containers been talking to each other, they must be in the same Docker network. You have a few networks created by default, but when you install Docker Engine or Docker Desktop, that also installs Docker Engine, or you can create network manually, or you can create networks from any Docker orchestrators like Docker Compose or Kubernetes or any other stuff, but it's only the way how you can connect containers. But instead of talking via localhost, because localhost only exists in one Docker container and in another Docker container, you need to use IP of the network. Or if depending on networks you restricted for whatever security reasons, you can use IP of the services. We'll explore the easiest way, how we can use it locally, is IP gateway of this network. So first of all, we need to understand what network is it using. Both of them are using actually. So if I run docker network ls command, it will show you all the networks. You might have a lot of them. You might have just a few created by default, like breach, host, and none. None is probably not the network you will use in real production environment, and host network is what is not allowed in the most of cloud networks. So the most of networks are based on breach network. Breach network means it creates its own isolation level layer from all other networks. So if you allocate some ports for these networks, they will not be available for other networks, and you can still connect containers in these networks using ports and IPs. So instead of connecting one container to another via Docker container port, we'll connect them via gateway port of this network. So how to get the IP of the network is we can explore or inspect network. So we can run the command docker network inspect. It's too big, not yet. Yeah, and then you can, for now just simply type the breach, that is the name of this network. Docker network inspect breach. And you will have in the end some containers. In our case, it's 2 containers. One is with Alpine, and another is with our service, web service running. But we are interested in this block, APAM. APAM block has a configuration of this Docker network. For the most of us, we all will have the same gateway IP address, that is 172.17.01, but it can depend on your subnet configurations and some operating system configurations. It might be 10, 15 something. So if you use systems like GitHub Actions or Bitbucket pipelines, it will be a gateway, a subnet 1015. For localhost, the most of you, if you don't have specific configurations, it always be the same. So if you copy this gateway, and now if I curl 172.17.01.8082, we'll have exactly the same response as for curling a local host from your laptop, from normal operating system. This is one of the easiest way to manually connect containers in the same network, right? So we need to keep in mind that containers can connect to each other, but there are a few ways, and the easiest way is to connect them via Docker network gateway. And this is where exposing of ports can help you to configure this in the easiest way. Right, so I will now show the test project, so you can have 5 minutes to relax a bit. Then we can switch to Dockerization of this part. By recommendation, I switched it to white font. It should be more visible for everybody. Yeah. So I have a separate Git repo with automated tests for this service web service that we work in the first part of this workshop. And tests are written in a technology called Cypress. Did anybody use Cypress in their practice? Great. So it's one of the most popular instruments to automate web tests now. There are a lot of benefits of using Cypress, and the biggest, in my opinion, of them is the easiness. It's one of the easiest way to really create some small or even recreation suite for your test automation part. So if we quickly look at the tests, for example, for users one, you can still use Mocha style of writing tests. You can have some hooks that will be running either before all tests or before each test, and you have custom names of the tests, and you can have some pre-defined functions in a separate support commands level, for example. And yeah, this is pretty handy. The code itself is really small, right? So like a few rows of code, and it's really powerful. Imagine create the same in Java or C#, it will be at least 10 times more. And you can have some auto synchronization coming from Cypress by default. It will wait until some elements are really editable before typing them, or before clicking into the button. It will wait automatically until it's really clickable. So it will help you a lot on synchronization or waiting part of some rendering of HTML elements, or when it's not really helping and you want to wait for some particular actions to be happened, like here I do, right? Every time I use the main page, I want to see that grid or table with data is loading, so I wait until rows length is more than 0, means at least one row is loaded. So because they really work very fast, you can prevent some failures because of flakiness in your test project. We'll not get a lot into details about this project. It will be available for everybody as an example. So I have similar requirements for this project just because of simplicity, but you can have completely different technologies like Java and Maven for tests, and you still want to execute it locally. And if you don't want or cannot set up the dependencies in localhost, you can continue using Docker to run test project as well. One more thing is I keep tests in a separate project, because not in the development project, because this is how I see it in normal world. Because in the most of cases we have dedicated team members for key part, or test automation engineers, or whoever developers are responsible for test automation. They usually work quite independent from each other from code perspective. It might be in the same technology like here, it might be in different languages, but in my opinion, commits or pull requests to one project should not conflict with others. So it doesn't give you any real pain in having multiple Git projects for test, and real target service or web service under test in separate Git repos. It's not a problem to have additional folder in your local or have additional pipeline. You can always connect pipelines to each other. You can trigger one pipeline from another pipeline, but you don't have conflicts when tests are isolated from development Git repo. But it's how I see it. I can imagine it might be different for many companies. Again, here I use the same technologies, but images will be different because there is Cypress on top of Node and NPM. I have it locally, so I'll quickly show how this tests look. So if I switch to this folder and run npm install, just to also have these not modules, it will build this project, and it will be much faster because I have much less dependencies for Cypress other than for my Vue project. Why? And now to run tests, I can have some commands pre-built. I want to run this test in heated mode just to really start the browser so you can see that they are actually testing something. I hope this platform is not broken. It will work. So yeah, you can see they're doing something, creating objects, deleting objects. Cypress has its own runner, so if something fails, it's very easy and handy to debug, go between steps, see what happened before and after each click or typing. So it's really handy tool for test automation, especially for some light version. So I have totally 5 tests. All of them are passed in 13 seconds with a heated mode, with all the stuff locally. So in CI it might be much faster. What I did also for latest part, I did some media outputs. In this case, it's a video file that will be automatically recorded for each run. And in case of failures, some snapshots will be captured automatically. So in your project, if you need it, you can have the example of the Cypress tests with all the configurations. So what we'll do now is we'll try to run these tests with the service and yeah, make sure it all runs under the same network. So before we continue, please clone another project. So if you go to Docker GitHub and in search you find for payment-portal-cy, that stands for Cypress-tests. This one. Let's give everybody a minute to find it. Portal-payment-cy-tests. There is just one line. And again, we go to code. In local tab, we are under HTTPS, can find a button to clone the link. In your terminal, you go to, let's see, work temp, and hit the command git clone and paste this one. Yeah, let's give everybody a few minutes to make sure this project is cloned. Okay, let's move on. So if you switch to this project and run the ls command, you will see the raw some files predefined, and one of them are Docker Compose. So this is what I'll focus on for the next few minutes. So if you want, you can open it locally, just follow me. So yeah, first of all, we also have Docker file, and Docker file for test projects will always be a little bit trickier than development one, because for example, for case of Cypress, we'll need to pick an image that has node, npm, all the required browsers, Cypress, and all the dependencies for Cypress installed. So yeah, before I go into details, if I open Docker Hub again and find for Cypress, we'll have a few images deployed by Cypress. So there is Cypress base, Cypress included, Cypress browsers, and Cypress factory. and some more by other companies. So they all are really different for different purposes. While Cypress base is really has some only required dependencies are installed, but no browsers, no specific versions of some transitive dependencies that you might need in your project. It usually, same as factory one, are used only if you want to build your own Cypress image with only what is required. For example, in your case, you only want to test in Chrome or Firefox, and you don't want this huge image that has everything that you don't really need. Browsers one is more extended. It has some browsers pre-installed, but don't have some specific requirements that you still need to do, some such as Cypress cache. What we will use in our case is Cypress included is the most is the biggest actually Cypress image that has almost everything possible on it pre-installed. The only downside is the size, because if I just check the last one, compressed is more than 1 GB, so uncompressed it maybe 1.5 or even more. So this is a downside of test images. Same for Playwright or Selenium. If you have everything pre-installed or you install it on top of what you have from Docker Hub, you'll have huge images. But luckily we don't need to really deploy these images somewhere. Usually on a daily basis we just prepare the image once and run tests on it. It's not running in some production systems, so it's more safe to have big images than for real services, as we checked in the first part. So in my case, I also have in the first row of Docker file this platform. It's a tag or a flag that you can use in your Docker run command as well. And I specifically need it for my MacBook because otherwise it will try to pull the IRAM based platform base image, and it does not work. Cypress developers know there is an open bug, and looks like they're not going to solve it soon. So whoever has MacBooks M1 or M2 chipsets, they have different architecture of processor that's called ARM one. So, and most probably this will not fully work for you. So just if you have M1 or M2 MacBook chipsets, bear with me. If you have Intel processor for your MacBook, it will work just fine as in Windows or a Linux system. But anyway, to just at least pull this image and build more or less correctly, I specify this platform to make sure we'll pull, even in MacBook, it will pull Linux image. And for included Cypress included version, I used the latest one. At least a few days ago it was the latest one. Why I don't use the latest tag, but from the latest tag I find the latest fixed one, is because imagine that one day they update some versions and your pipelines just stop working, and you need to fix it by finding the right tag that was before this upgrade. So it's much safer if you use always this specific tag, and if you need to update it, you can regularly do this and manually check that it all works fine before you use it for real pipelines. For my case, it has some specific versions of Chrome, Node, Cypress, Edge, for whatever reasons. And the rest is very similar to what we had for the first part. We have a working directory. We can call it any way we want. We copy all the files to this app folder we just created in the previous row. We run npm CI. It's actually the same as npm install, but it only makes sure that it only uses the dependencies from package log, ignores the possible changes based on the Node version, because Node here is a little bit different from Node in official image. Then Cypress install will install all the Cypress based dependencies, and Cypress verified it will check that Cypress cache and everything is configured correctly before you can proceed. I will not build this image locally and run the container because Cypress requires the project to be prepared and built before it can proceed. So we will switch to Docker Compose right away. So Docker Compose is a technology that can be used as an orchestration for your Docker containers. Means instead of, as I did previously, manually run one container, run another container, find a way how to connect them to each other, like IP gateway of this network or some other way to connect containers inside the network. Docker Compose can create a network automatically for you. It can have a specification for different containers as much as you want. You can set dependencies between these containers all in one file. So let's go step by step. For version, we can specify just the major version, like in my case 3 is enough, or you can use some specific version like 3.8, and everybody who is trying to run this Docker Compose with a version lower than you require will fail. And warning will say that you need to upgrade your Docker Compose before you can proceed. So services block is a list of container specification that will be running as Docker Compose services. So again, Compose is orchestration of containers. In our case, we'll have 2 containers. One is with a payment portal that we worked on at the first part of this masterclass, and second part we'll use this Docker file to prepare this project and run tests against the first one. So let's check how the first part is configured. You can, there is a nice tricky part in Docker Compose that you can actually get Docker files from different Git repos. You can have custom names of Docker files, but you can also have a custom space where this Docker file is located. In my case, it's even different Git repo. So Docker Compose will automatically clone it, get whatever it needs, build the image, and remove it on the fly. So Docker file name is Docker file multi-stage that we already used in the previous step. The flag restart always tells that if something goes wrong and it fails, it will start to restart this container with microservice again. Ports is the same part as we did with manual Docker running, with running Docker run command with the pointing 8082 to nginx based 80 port. So this part will again being completely agnostic from what you have locally. It will get the Docker file multi-stage from this Git repo in main branch and will build this and run locally. So the second part, I call the service E2E. Build dot means it will get the context as we used in Docker build command using Docker file. Because I don't have a custom name, I don't need to specify it here. Otherwise, you'll need to do it like here, Docker file, and provide a custom name of your Docker file in this project. Depends on is a block that will wait until the first part is really clone, build, and run the service. And there is a very nice tricky part where you can inject environment variables on the fly inside your container. So for my container that will run tests, I inject the environment variable called Cypress underscore base URL to one that will point these tests to this container. So Docker Compose also create DNS that instead of 172.0.701:8082 will point it to this DNS inside the Docker network. It will be payment portal. So we can go to HTTPS payment portal, and it will be the same one because Docker Compose takes care of it. So why this one, right? If I go to Cypress config JavaScript, I have some base URL pre-configured by default. This is pointing to HTTP localhost 8082. So if you want to override this, for example, for CI part, You can inject environment variables starting with the Cypress uppercase, coming from official documentation. So it will be using instead of the configuration you have in Cypress config. All right. So command, because I did not specify a command here, like I did for our web service, I need to provide a command that I need to run once this container is up and running. So npm run tests, let's go to package.json, will execute Cypress run. It will be in headless mode by default. Yeah, it's another big problem of headful modes, as I before ran from localhost with a real browser. If for any cases you need to run real UI, like real browser in your Docker container, there is a default technology where you need to connect your display port from your operating system to your Docker container and connect them via XVFB, but this is really hard one and I don't want to go into details. So we'll run tests in headless mode, means browser will not be really appeared but running in background inside Docker container. And the last but not least, I need some output from execution. At least I need some XML result that will be generated by Cypress, and I need some artifacts like screenshots and videos, if there are any. So that's why I create a volume. So I say inside Cypress folder, mount it to app Cypress. And app Cypress comes from this Docker file specification. So again, Docker go on, please.
You're showing stories here. Let's imagine that the app crashes. Now we look at the screenshots from the script, the Cypress test framework.
So if it really crashes for starting, or if Nginx cannot start the service because of broken Docker file, and this part fails, this one will not even start it because it has a dependency. If app is started but it's broken because developers did a mistake, test will start. It will run all the tests. If all 5 fail or one of them failed, then we will anyway finish them. We'll create a report, we'll create screenshots, videos, and we will save it in localhost. So containers will be closed, exited, removed, but we will still have artifacts such as XML reports and screenshots and videos on localhost.
And from the application container, will you be able to choose those?
Not from this configuration, but yeah, I will quickly show it, yeah. Because of Nginx is not the best service where you can actually check logs. It has only Nginx-based logs. So if you really want to have some metrics from containers, you need to publish this metrics somewhere. I didn't configure this part, but yeah, you can imagine if you need to check the container, why is it crashing, you don't usually use Docker logs, but instead you go to some metrics system or log entry system where you can query and see why is it failing. For example, Kubernetes, OpenShift, or whatever you have for orchestration in the real production system. But yeah, I'll get back to it soon. Okay, so to work with Docker Compose, we have a few commands. So one of them is Docker Compose build that does not run any apps. It does not actually start any containers, but it, in our case, it will pre-build the context of what we have in Docker Compose and all the related Docker files. So if in this project I run the command Docker Compose build, that is not required, because if I first time run the command Docker Compose up, it will run Docker Compose build as a part of it. But in pipelines, it's very nice practice to have it as a separate one, because if build fails, run will not work as well. So what build actually do is it will pull this repo in main branch it will build the web service Docker image from this Dockerfile multi-stage spec, and it will save this image locally for Docker Compose. It will also create another temporal Docker image with all the cache and context, and will save it in Docker cache for the second part based on this Docker file. So it will pull this huge Cypress included image, and it will check that it can be all installed. Again, for whoever has non-Mac M1 or M2 chipsets, this is not required. It will work for everybody, but if you have non-Mac, you can simply remove this. Right, I only included this platform Linux AMD 64 for Mac M1, M2 users to be able to at least do some part. Yeah, you can always run some more flags to check the progress, like plain text, and see this thousands of row of output to see how it's going, or you can go through this overview and see what it did. So it actually get git source, and it get the Node 1620 Slim image. It built everything with npm install and npm build, and then on stage, in the second stage, it uses nginx. It copied dist folder as we saw before, and it created some temporal image and called this based on some Docker Compose configuration. In our case, it's name of the project plus name of the service. Payment portal CI test payment portal. And second part will pull the Cypress included image. That is really big one. I'll quickly check it locally. Images. Yeah, it's up to 1.5 GB on local host, so I can imagine it will take some time for us now until everybody finished it. And in the end, it actually failed for me because of I have nice MacBook ARM. So I will now switch to CI to show how it actually looks until everybody with the non-M1 or M2 MacBooks have the same problems. Otherwise, it will work exactly the same as I will show in CI. So why I did it all actually is to reproduce continuous behavior in some real CI system, because the final goal is to get all the services containerized, get all the tests containerized, and run it in some CI system. Because I used GitHub for hosting, and GitHub has free pipelines that you can use out of the box. I configured GitHub Actions. So Actions is a GitHub feature that allows you to configure pipelines, same as GitLab, CI/CD, or Bitbucket pipelines, or Azure DevOps pipelines, JFrog pipelines, many other systems. Allows you to, or Jenkins, TeamCity, and so on, allows you to prepare some spec files that will be used to generate CI/CD pipelines and run your, ideally, Docker-related builds. So in the most of cases, it's all running under Docker. If you have your own servers with runners, for example, for GitHub or GitLab, you can use shell runners where you can install Java, JavaScript, and run shell commands. But in normal pipeline, especially in cloud, it's only allowed to have Docker specification to run exactly the same commands as we did before, but in CI. So in some machines that owned by GitHub, we can specify the specification that will be running remotely. And this is really what you can use in real work. So let's see the pipeline, and let's see the configuration first. So for for GitHub, you should have this project folder GitHub workflows, where you specify YAML files with configuration of GitHub. And it's really handy because, again, we used YAML configuration for Docker Compose. You will have YAML configuration for GitLab, for Bitbucket, and for big configuration infrastructure systems like Kubernetes and others. It's very common format, and this is what I especially like for GitHub Actions and GitLab CI. And the most of things that you can run right here, you can actually find in the first page of official GitHub Actions documentation. So there are a few blocks. Let's explore them. On means when do you actually need to run pipelines. In my case, I only wanted to run it on git push, so I only had a push as a flag on when to run pipeline. So for every git commit push or any merge from one branch to another, this pipeline will be automatically executed. And you can have a couple of jobs. I have it all at one job because I already have a compose configuration. I just need to run Docker Compose up, but with some artifact segregation in the end. You can have a custom name. It's optional. You need to specify where do you need to run this. So GitHub by default for free gives you an ability to run either on Mac or Windows or Linux. I used the free Ubuntu latest machine. I don't need to fix it for a specific Ubuntu version, or you can find some specific Ubuntu version if you need to run it on some specific operating systems. Because this project will create some additional files on top of Git repos, such as XML reports and media files like videos, I need to give this pipeline permissions to write files. And actually you have steps. Steps is a subsequence of procedures that you need to do for a specific job. The first step, checkout, it just uses built-in mechanism of GitHub Actions to pull your repo and check out to the latest version of this branch and make sure it gets the latest commit of this branch. I don't have any specifications here, means it will use default branch that is main one, and it will get the latest version for this pipeline. Then I have another step with the name build, and this is where actually all the magic happens. So Docker Compose up is a command of Docker Compose that will start all the services, all the containers, and a flag abort on container exit will stop the execution once tests are finished. Again, it will not work on my local host, but if I start it, all this command Docker Compose up with abort on container exit will, again, if not build, if not npm build Docker Compose build is executed, it will build, and then it will start the service, and then it will start containers. And if I run Docker PS, it's old one, Docker PS -a, that also shows killed or exited containers. It will let me kill this one quickly. If you want to clean up whatever you don't need, you can always use docker rm -f, and then instead of listing all the containers and copy all the IDs, you can provide $ brackets docker ps -a and -q, where docker ps -a is the output that I showed, and -q will only print out IDs. So now docker ps -a has nothing. So if I rerun Docker Compose up, in case if it all works fine, if no MacBook, I will have all the containers in Docker PS afterwards. In my case, I have nothing. So let's get back to CI part. So whoever has Mac with Intel processors, Windows, or any Ubuntu or any other Linux terminal, you can still use the Docker Compose up command to run all the tests locally. So how it looks in CI. It has some actions that I listed. It has this checkout, as I explained. It just clone the repo, and the most time-consuming command is the build one. So it ran the command docker compose up with a flag abort and container exit. It created some network. It's another network built on top of bridge network that are used by containers, and we see some stuff that we saw locally. It uses the node image for the first part. It downloaded. It ran the npm install, and it will be big output. Then it ran npm build, and for the second part, for nginx and alpine, it downloaded. It copied dist folder from the first stage, and it started the container. It has some information about how much does this container takes in the pipeline, 280 kilobytes, and then another part that is for tests. It cloned the Cypress included image, and then it ran npm ci command that installed node modules folder. Yeah, there is a huge output, and Cypress verify said it's all good, and it said creating containers. Payment portal is created, this container with test is created, then it started the command npm test, npm run test, and we can see the output of Cypress. Yeah, let it give some time to load. And it has some results, like I was running locally, gone. Yeah, it's free and it's slow. Almost the end. Yeah, there is a lot of information, but it can be really useful in case if something fails, so you have all the information in CI. So it says all the 5 tests are finished. Then I have one more job, one more step to upload artifacts. So what we do here, we have a bit more complex configuration for CI.
I'm sorry, I was waiting for you to pause. Wanted to ask you a question. I'm sorry for the interruption. Can we just for a second talk about the reasoning, right? Because GitHub Action already runs in a container. What we're seeing here is we are building 2 containers inside a container. That's the GitHub Action, right? So if we want to start a service inside a GitHub Action, and we have a database, I can understand to start the database on a container, right? Which is an image that is already pre-built, right? But in this case, what you're doing is basically starting both the tests and the test inside the container and the service inside another container,
Yes.
right? I'm not sure what is the benefit of that. Can you?
Sure. So the question is where to run your tests.
Yeah.
You can run it on localhost from your terminal. You don't need any containerization at all.
Sure.
But in real systems, developers might want to test their app independently from your laptop, right? If you cannot run tests locally, they need to have some systems where to run tests. So either you publish your test to some server, some local server, where they will be available and developers can somehow connect to this server and run tests, or they can run your tests in Docker. But to connect your tests in Docker to their service in Docker, you need to make an orchestration of Docker containers. You might have multiple services. It might be database, Redis, microservice, another microservice, front end, all running together with tests in one Docker Compose configuration. So in this way, you can get all the components of your app, such as database, services, front end, and tests running in one network, test it quickly all together based on the same specifications that you will use for your development code for production builds, and make sure you test it in the same way as you will deploy it for the end customer. So it's always a question where to run and when to run your tests.
So it totally makes sense what
Mhm.
you're saying to me, right? But the GitHub action has its own container, right? And it has access to the repository, right? So it can clone the repository and run the test automatically, right?
Mhm.
We don't need that. So I'm asking.
Yes.
I'm asking. I mean, why do we need another container for that? We are
It's
already
not Compose is not a container, it's orchestration. It's just a tool that works with Desk2 containers via custom Docker network. In real CI systems, in real self-hosted runners, you will have very limited access to your Docker networks. And trying to do the stuff that I did before with this inspecting network and trying to connect them via IP gateway will probably not work on real environment. And it's really hard to get this network IP on the fly, right? And it will be dynamic every time, so you cannot save it as configuration. So the only way is to run all the development components and tests in the same pipeline is to orchestrate them with a tool like Docker Compose. It's just the easiest tool. There are multiple ways. You can create a Kubernetes cluster with a component like TestCube and configure all there, but it's much more complex. That's why I wanted to show the Docker Compose way. The others are just a matter of configuration. Compose is like 20 rows of YAML code that will run it all together. Again, it's always a way of where to run tests and how to show them, how to expose results to all your team members. So if you have some pipeline where tests can be automatically triggered or manually triggered by anybody in a team where they need it, either developers, QAs, or product owners, does not matter, and they can run tests on particular branch and see the state of the app, or automatically trigger tests by any development code change, it will give a quick feedback on how your app works actually right now. And with this part of exposing test results, you don't require to anybody to run tests locally or build an internal system to see the test result or go through these 400 rows of log to see what's the output. Because when test green, we need some more confidence to see what's the output, right? So with mechanism like this, yeah, you can always go to GitHub Actions and check what pipes do they have pre-built for you. And for upload artifacts, they already have one. If means when do we want to upload artifacts? I'll want to upload artifacts even if tests fail, obviously, to check why they fail. And I say, please get all the files in Cypress video and Cypress snapshots and upload them to GitHub Actions. So if tests fail, or if you want to check whether they really passed, so right here in the top, if I if I go to Actions and just open any pipeline, right here the artifacts will be available. So in this case, it's simple zip folder. I can download it. Gone. Doesn't matter. So I can download, I can open this zip, extract, and I'll see some videos. And I can, yeah, if I want, I can watch how tests were executed, what they actually tested, and I don't need to run this locally. Especially if tests fail, it's super useful, right? So you can check from screenshots and videos what happened, why they fail, so developers after each code change can see with this test integrated in the pipeline what actually went wrong. And another nice thing here is publishing reports. So there are many ways how you can publish test execution reports, and for some companies, especially working in payment industry, you might have a requirement to have a test execution report because of compliance. So for any code change, you need to have this TER, test execution report, and you can actually have built-in systems in GitLab or GitHub to publish these reports. For this purpose, in Cypress config, I had this little configuration. So I had report is JUnit because GitHub has a free available parser of JUnit reports out of the box. And I said mockup files will be created under Cypress result test output with a hash.xml file that will be automatically parsed by GitHub Actions. So with this configuration, with a custom Docker image created by, I don't know, some guy, I just like this report. There are dozens of them available in GitHub Actions pipes. You can skip having some separate tool like Report Portal or Allure or any other, but simply generate XMLs in the CI and parse them with the tool, like this one. Means always same as in the previous step, I always want to have this report parsed, and reporter is coming from documentation of this one. We'll not go into details. So, but how it looks, it will automatically create this page, and you will have a very detailed report of all the tests with the links to these XML files, and if you have some logs, custom logs in your test, it all will be available here. And you might want to, if you want to attach snapshots and link them to failed tests, it will always be here, and especially for failed tests. Let me see if I have some failed tests before. I should, yes, like this pipe, come on, like this pipeline failed. So if they fail, you can quickly get the stack trace in CI, and you can link again the screenshots here and see the raw output and see why tests actually failed. So developers can have this abstraction layer from your tests, and can still have this running automatically in some independent CI system in completely different machine, and have a quick feedback for them, and they can actually use it to understand what went wrong, especially for failed pipelines. From my practice, they don't review past builds a lot, but business guys like managers or product owners might want to go to the latest pipeline, open it, and want to see a page like this to understand at least what are you actually testing, what tests do you have, what's the output, and maybe see some screenshots and so on. It will be very useful for these agencies that require test execution report because of some compliances. So with this configuration, you can reuse whatever you have for local machine, for your Linux or Windows machine, and you can run it all in localhost, and in exactly the same way with a little YAML configuration like this, you can have it all up and running and automatically parsed in some CI/CD system, even for free, like GitHub Actions or GitLab CI/CD and other systems. I think this is a very nice way to use containerization because we all have in different laptops, operating systems, and capacity of laptops can be quite agnostic from code base and test code base, and have it in exactly the same way running as in some CI/CD system, where we don't have any ideas what's the machine actually, whether it's Red Hat Linux or Ubuntu or whatever else. We don't want to control this, but have it all the same, so everybody in the team can run it in the same way, and once it's already locally, you can reuse it in CI/CD for your normal builds. It's actually what I wanted to show. If you have any questions. Cool. So I have quick overview of this one in diagram. So I know it's quite complex to understand this CI/CD, so I just listed it all as I understand. So GitHub Actions in our case, or any other CI/CD system, just creates a specification of how do you want to run your Docker related containers in some configuration, like compose, that in our case starts to container and parses all the artifacts and reports and expose in some GitHub internal mechanism. So maybe it will help you to understand it a bit more in details afterwards. This presentation should be allowed for everybody. In the end, you will find links to my Twitter, where I will upload my presentation to recording to YouTube, and I will send a link to Twitter. So if you have this presentation, you will have a link. I hope by tomorrow it will be there. It will take some time to upload it to YouTube. And yeah, if you have any questions, feel free to reach out to me afterwards, or just find me today or tomorrow with any questions you have. I'll stop the presentation